Lippisch P.13a. The Lippisch P.2o, P.13a and P.13b were related design projects for a ramjet-powered delta-wing interceptor aircraft, studied in 1944 by German designer Alexander Lippisch. The P.2o and P.13a were unarmed, relying to reinforced wings to arm its opponent. The P.13a and B were to be powered by producer gas, made in flight from powdered coal. During 1942, while still working on the Messerschmitt Me-163 rocket fighter, Alexander Lippisch developed a sharply swept, leaf-shaped delta wing, which he believed was capable of supersonic flight. He conceived the idea of a hollow delta wing, with its interior shaped like a ramjet duct. As an interceptor fighter, it would achieve supersonic speeds, but would carry no armament. Instead, it would be heavily reinforced and would ram its opponent. Initially conceived as a disposable machine, with the pilot bailing out at the end of the mission, a landing skid was later added. Launch to ramjet operational speed would be via catapult or booster rockets. The resulting design was initially assumed to use conventional liquid fuel and designated the P2O, but Lippisch had also become convinced of the benefits of solid fuel and adopted this power source at the P13. From autumn 1944, Alexander Lippisch had opened his own development office at the Aviation Research Institute Vienna. In Wiener Neustadt, Lippisch worked on the further development of the delta wing, cold jet fighter aircraft Lippisch P.13a, which at the end of the war became part of the emergency fighter program, and finally taken over by the occupying United States Armed Forces. The solid fuel-powered P-13 was one of several distinct Lippisch design studies to be so designated, and became identified as the P-13a. It underwent much the same variance of form as the P-12, being presented in a brochure with a large fan and integral raised cockpit, with an articulated, double-hinged landing skid. The wing-to-railing edge is angled forwards, and the downturned tip surfaces have been discarded. The outer wing sections could be folded upwards for transportation by rail. A variant with a rectangular canal foreplane was wind tunnel tested. This was not really consistent with ramming, and there are other indications that conventional gun armament was being considered. As conventional fuel were in extremely short supply by late 1944, Lippisch proposed that P-13a be powered by coal. Lippisch soon came to conclude that this might even be more effective than liquid fuel, as the location of combustion was more precisely controllable. Initially, it was proposed to employ a wire mesh basket, holding even-sized granules of brown coal, placed in the lower region of the internal airflow. The burning coal gave off carbon monoxide gas, which was mixed and combusted with the upper airflow downstream. The arrangement proved inefficient. To replace it, a spinning circular basket was developed, revolving on a vertical axis at 60 rpm. The hot exhaust would be mixed with cooler bypass air to improve thermodynamic efficiency, before being expelled through the rear nozzle. Other fuels considered promising due to their ability to generate flammable vapors, included bituminous coal or pine wood heat soaked in oil or paraffin. A burner and drum were built and tested successfully in Vienna.